Saludos, ¿me escuchan? Okay. Saludos, ¿me escuchan? Oh, I guess so. Hold on. Okay, so I think everything's working now, except for my video. I can't seem to get the video to work. Why is that going? Oh, let me turn this off. There. Is that better? I don't know. Things are flashing. Lights are flashing. All right, so you see and you hear me. According to my reader, very good. All right, so any questions for me? Hay preguntas. Have you looked at the platform? All those documents, and there'll be more, are meant to prepare you for the test on March 1st. And the test will be on March 1st. I think that's Wednesday, right? I'm going to double check. It's on Wednesday, and it will be during the class time. Okay, so that's what we're preparing for right now. So you need to review these exercises, put the important formulas on one page, and be comfortable using them with your calculator, all right? Also, I'm going to ask that you submit your handwritten solutions on the platform. There will be a assignment icon for you to upload your solutions. As far as I know, you should be able to translate these videos to Spanish if that is necessary. If you have trouble with the translation, let me know. Coral, yes, I'll put the test there and you will upload it to Moodle Coral. Yes. So even though this is a online course, they schedule the time, so I get to use that for the test, you see. So you should be available for that test on Wednesday, March 1st. Okay. Okay, so shall we start here? No questions? No other questions? Any comments on my sound? It's clear? All right. So for latecomers, I am not putting my video up because I'm not sure why it's not working and I don't have time to troubleshoot. All right, so let's see where we left off. Let's go back a bit and remind ourselves what we did. We did a lot, right? We did. Let me review the formula sheet for a moment. Let me pull that up 1 minute. I'm going to bring it up. All right, so this document with formulas on it is available on the platform. It's called Finance Formulas. And it shows you the basic time value of money formula first, and then the net present value formula that we use, cash flow plus the present value of future cash flows. And then we use that rule for mixed cash flows in general to value assets and investment opportunities in terms of the present value of future cash flows. And that's what we do with these simplifications that we learn. So we learned all of these. We learned this formula sheet. All right, so this is, you can use this as your formula sheet. You can work with that. I recommend that you write them out yourself so you're comfortable with them and you practice writing your formula. Okay, it's not enough just to know how to use the calculator. It's not enough just to solve problems on paper, you need to know both, right? To use the finance keys and the mathematical or scientific calculator as well. So we did all of this, and now I promise you that all you really need is an understanding of timelines and the two formulas, the basic time value of money relationship and the perpetuity relationship, and you get all these other formulas from there, and I showed you how to derive them and how to use the time value of money for most of them on your calculator, except for this one. You have to practice entering this into your calculator, and I have some exercises for your practice. All right, let me get back to what we were doing. So we're going to talk about bonds next. So the first type of bond you were introduced to was the British Consul bond, and that's a government bond that pays a set amount infinitely or indefinitely. Okay, so that that's a very specific type of set of cash flows, perpetual cash flows. In reality, bonds are sold in order to borrow money from the public, and the governments can do it, and corporations can do it, all right, or they do it. And that's what we're interested in. It's standard for bonds to pay a set amount in a number of years, and people purchase this bond with an interest rate in mind. And I think I mentioned it to you already. Every problem will have an interest rate, but in the context of the problem, it'll use a different term to refer to the interest rate. When it comes to bonds, we use yield to maturity. So here's a problem. You treat this like the interest rate. What's the fair price of the bond? Why don't you try that and tell me what the price is? All right, so you got Ricardo 747.26. Right. So I want two things from you. I want you to tell me about the formula that you used, and I want you to tell me how you used, or if you used the finance keys to solve this problem. Remember, you guys can call me if you want to use your voice. I can put you on the microphone. It's probably a better way to do it that I haven't sorted out yet, but I think that's the best I can offer. Aha, is something missing? No, that looks good. 1,000, 1.06 to the power 5. So it's a basic time value of money formula, right? And so you entered it like you do the regular TVM problem. Is that correct? All right, so this is known as a pure discount bond. We'll talk about what an unpure one is. In particular, a pure discount bond has no coupons. Now, coupons are a way of paying the return or paying the interest over time. In this case, there are no coupons, so the interest is just paid at the end. So the interest implicit in $1,000, and bonds have either what's called a face value of 1,000, and notice conveniently that's FV, a face value of 1,000 or about 5,000, right? So 5,000 and 1,000 are standard face value. In this course, I stick with the $1,000 face value. And remembering we use the term yield to maturity for the implicit interest rate. So here's the formula that he used. And in a test situation, I want to see this and I want to see the result, right? So you can show me this. Sorry, do that again. I don't need to see this formula. You might feel inclined to write it down, but all I need to see is the formula with the values entered and the results, okay? Because there's no need to see this. Also, writing this down gives no points. I need to see the formula. I need to see that you understand the relationship. This is how it was entered from left to right and compute PV. So this is a familiar formula because it's the general or the basic time value of money relationship. But in this context, this is the price of a bond. And the bond is purchased at a discount. You're going to get $1,000 for loaning $747.26 now. And implicit in that is a 6% rate of return each year. Okay, so now if you don't have any questions, I'm going to go into the coupon bonds. So you know what a coupon is. Coupon is, you can cut it out of the newspaper or you can get it online and it gives you a discount when you buy something, or it gives you some money back, like the Walgreens. If you guys sign up for Walgreens, what do they call it? Points. Anyway, so you sign up for Walgreens and then you get like discounts and offers and things. Okay, so the idea of having a part of the ability to make a claim is what the bond indenture, the bond contract provides. In the past, you could actually clip off or cut out the coupons to go pick up your payment each period. So let's look at, first let's talk about the terms. I'm going to rename these variables for the context of a bond, and then I'll use it very casually. So this is the so this would be called like the duration of the bond or the number of payments or term to maturity. This is called the yield to maturity. Maturity, right? Like I think it's a similar word in Spanish, right? Maturidad. And then this would be your, where there are no payments, there's no coupons, this would have been the coupon. There are none. And rather than calling this the future value, we refer to it as the face value of the bond. Remembering, if the screen gets blurry, just reload. If our conversation is disconnected at any point, I lose the chat, unfortunately, and I haven't sorted out how I can save that, but I will try, because I think we were already disconnected once. Looks like it. All right, so here is an example of a coupon bond, and I want to find the price. So what's the present value of future cash flows to bondholders here? A 6% coupon bond pays $1,000 in 5 years. If bonds of comparable risk have a yield to maturity of 6%, what is the fair price for this bond? All right, so now we're qualifying what yield to maturity is a little. And I mention the coupon rate. Now, which one of these rates, well, I guess they're both the same number, but which one is the interest rate? So now I have to be very careful, because I had to shrink that to make sure you see that it's $60 every period, and we assume at the end of the period, right? Unless I tell you otherwise. And then here's the face value of the bond at the end. So if it's not said, you assume it's $1,000. Okay, that's what we're going to assume. Okay, the first 6% is not the interest rate, but that's a good guess. I admit it's confusing. That's why I'm asking the question. So it must be the other one, right? So this is the interest rate. The yield to maturity is the interest rate. This is the I. So what in the world is the other thing? This is the coupon rate, and it helps you calculate the payment, which you can see from the timeline is $60. So how do I calculate that? I calculate that by taking the face value times the rate, and that tells me I have to I can expect $60 every year. Oh, I don't want to square off all that. I just want to highlight in blue here a formula for you. So you need to know this, right? So to calculate the payment, it's the rate, C, times face value. So what you have here, you have this set of payments that is an annuity, and this lump sum amount, the face value, which is just a lump sum at the end of 5 years. I'm going to use a different color because I don't know, people can't see that. So there's two parts. There are two parts, and that means there's two parts to the formula. So can you write for me the formula that you would use for this? I appreciate when you answer my questions, so don't feel shy. If you don't get the right answer, you're very bold to try. I mean to ask the confusing questions so I can highlight the correct answer. So what should the formula look like for this? And what is the price? What would you get? No one dare? Okay, well, you have first an equation for the annuity, and then you have the lump sum basic time value of money expression, and there it is. So this is a combination of the formulas in the formula sheet, and you should add it to the formula sheet. The main thing is to remember that there are two parts. You're using the annuity, so I promised all you need to know is the perpetuity formula and the basic time value of money, and you can solve, you can use and combine them to solve several problems, most of the problems that I present you. I think all the problems I present you. So this is just that, an annuity and then the basic time value of money expression here. You don't have to punch this in with your scientific keys. Use your finance keys, the TVM row. And what you're going to find is the price is 1,000. So try that. So, and then think about it a little bit. Think about what that means. No comments? Nobody? So this is surprising. You should ask yourself, why would anybody pay $1,000 to get $1,000? Well, because they're going to get 6% a year and capture that rate of return, where this is what they're interested in, right? So they're interested in trading off their consumption today for the price of 6%, and they feel comfortable doing that with this bond. And that's why they would do it, because they'll get $60 for each bond. They might have more than one. $60 every year. So we call this type of a bond par value bond. So from here on out, when you hear about a par value bond, the price is just the face value of the bond. And it is where it's the coupon rate and the interest rate are the same. So you're getting your interest through coupons. So what if that's not the case? What if you're not getting interest through coupons? What if, well, before I go there, this is how you plug it in. You notice there's a number on every key. This is the first type of problem. So bonds make you use every key of the TVM row to find the answer. So make sure you can plug that in for a term to maturity of 5 years, an interest rate of 6%, a coupon rate or payments of $60, and a face value of 1,000. Make sure you can punch that in. In the test situation, I want to see this. That's what I want to see. All right, ready? So here's a problem where you have the C not equal to the I. So this is the C coupon rate, and this is I, the yield to maturity, or we can call it, how many other names we have? It's the interest rate, it's the rate of return, It's the discount rate for the bond, okay, but we call it the yield to maturity, and we say for bonds of a comparable risk. So in this problem, we're taking the information from the market about firms possibly that issue bonds in the same industry, and we think about the risks associated with loaning money to that corporation. And what are the risks? Well, bond holders have a claim on the profits of a firm. So a firm pays for its operations, right? Pays any taxes, makes all these payments, and then in terms of their payments, paying interest to creditors, to bondholders, is part of those expenses, right? And those actually, this is going to come up later in the course, those payments are actually tax deductible to the corporation. So we're going to talk more about how that affects things later, but that's very nice. They have a commitment, they have a contract with the firm in terms of what's called the indenture of the loan or the bond, and they expect that, but they might not get it, right? They might not get the guaranteed amount if something happens to the firm. If they're and if they don't pay, if they default on one of the payments, if the firm defaults on one of the payments, the bondholders as a group, as investors, can actually take legal action against the firm, and thus they have to weigh the risks of doing that, because if they do that, they may further affect the operations and the revenues from the firm and the cost of doing business for the firm and not get paid at all, right? So anyway, there's risks that have to be considered, and this is what they want. They want 6% to invest in this this bond. Investors feel that way. So that's the interest rate or the yield to maturity. And here's the timeline, and I'm going to shrink it again because I want to show you that base value there. All right, so what do we expect? Is this going to cost more or less than the par value bond? What's the price? Is it more or less than the par value bond? I'm waiting. Ricardo just went for the numbers, right? But understanding it's going to be priced less. Why? Because the yield to maturity is 6%, but they're only getting $30 every year. So that's just a 30% return. And then they get the face value. So they've got to be given a discount for doing that. All right, they have to be given a discount, and Ricardo figured out that it's 873.63, which, let's see, is correct. Okay, so this is called a discount bond when the coupon rate is less, so you're getting less every period than the yield to maturity. You've got to be incentivized with a discount as an investor. That's the minimum price. If bonds were selling for less, it would be a deal to buy that. You'd get some sort of profit because you could buy it and then sell it to people for $873.63. You'd have an arbitrage profit of doing that. And we'll talk more about why we use this number rather than other numbers when we talk about efficient markets and efficient market hypothesis. So this is the most you'd be willing to pay for this deal. Any questions? Any questions about how I'm doing things here in general? Comments? I see viewers going in and out. Maybe that's the connection that's dropping them, but I can tell when you guys are watching and when you're not. But as I explained, you don't have to be here. The only thing you have to be in the classroom for is the test. All right, you have to be there for the test. The classroom, it's not a classroom, is there? They didn't give us a classroom. I need to verify that. Maybe I did get a classroom. Now I'm thinking about it. Yes, I did get a classroom. If you need to go to a classroom to write the test, I have to confirm that. I'll have to let you know. Okay, I have to make a note about that. That's in case some of you are on campus and you need quiet to write the test, right? Yeah, I have to verify that. Okay, the coupon formula looks complicated. Yeah, because so I noticed this with many students. I can teach you one thing and I can teach you a second thing, but when I put them together, students don't like that. But you have to get comfortable with that because I'm going to do that a lot. Okay, you're going to learn one concept and then I'm going to talk about another concept, and then there's going to be situations where I can combine them. Okay, it's very creative here. So yes, it looks complicated, but just remember this picture. Just remember this image, and that's why I have them drawn on the formula sheet that I share. So get comfortable with that formula sheet. Okay, so this is called a discount bond. Plugging it in again, we use all the keys of the calculator, all right? So you have to get comfortable writing it out. You have to write out this long thing. Yeah, I remember way back when things look complicated to me, but when you understand them, it's always easier. All right, everybody can get that? Okay, I'm assuming you all got it. No comments. Let's see. Oh, I skipped that. Okay, so here's the reverse example. Here I have a bond. I want to price it. This is the timeline, and we want the present value of future cash flows, remembering that what this rate means. So we have two rates, and that definitely confuses you at the beginning. So that's the coupon rate that's used to calculate the payment, and you need this formula to do it, right? And then the time to maturity is 5 years. The face value is always 1,000, and this is the yield to maturity, or the interest rate. So we have an annuity and a basic time value of money formula that we spell out like this. And what is the price of this? Well, with $30 every period, at the end of every period, we got a discount, right? The price was less than $1,000 because we were not paid the interest that way. So we got it implicitly by getting it at a discount, less than $1,000. So in that way, that's how we got our interest payment of 6% on average per year. I'd say on average, but we got 6% per year. And here we're getting more than $60, we're getting $70, so we should pay extra for that. The price will actually be more than 1,000 when C is greater than I. So this is called a premium bond. Okay, give me a price for that one. Now you have all these notes, they're in the platform, but if you don't look at them and you work with me, you get some practice. Very good. All right, so again, the formula, the two parts, and I'll tell you, most students forget the two parts. They used to always ask this on a accreditation or what they call a valual assignment, and the students, like a sad majority of them, would get it wrong. Very disappointing, but there are two parts here. All right. Okay, so those are the steps to entering it from left to right. Does anybody need to see me do it on the calculator, or are you okay with yourself? So we have about a half an hour left in the class. All right, so very interesting enough, just like the time value of money relationship and the annuity problem, we have a formula for bonds, coupon bonds, that we have a formula that has 4 variables in it. So as long as I know the 3 of the variables, I can solve for the 4th. And until now, we've been using it to price the bonds, but there's other practical problems. For instance, what about when bonds sell on secondary markets and you want to compare them? You want to compare them and see, which bond you want to invest in. If you're interested in fixed income investment, it has a lower return, but a more guaranteed return, more safe return. And in fact, if you're loaning to the government, that's backed, if you're loaning to a sovereign government, that's backed by the government. So what happens is if the government is seeing that they're not going to be able to pay their creditors, they can increase taxes, right? So they have that ability to increase taxes so that they can accumulate money to pay creditors. Well, in the case of non-sovereign governments like Puerto Rico issuing municipal bonds, they got in a lot of trouble. In 2015, eventually they had to declare, the government declared a type of bankruptcy because it couldn't pay. It couldn't pay back the lenders, right? And so unfortunately that happened, and we are still getting out of that. Just last year, there was an agreement reached after many years, 7 years, an agreement on how to pay. This is all the lawyers and the junta that you must hear about, the junta control board, fiscal control board, that's overseeing the decisions about how to pay these creditors. So they had to take a rate cut, and they're not making exactly how much they plan to make off of the debt. Also, the money's coming late. They were defaulting on payments for years. So in that case, the government of Puerto Rico couldn't just simply raise the money because they were dealing with an economic crisis as well. So that's the situation for those are the considerations for bondholders. So prospective investors looking at bonds for sale, right? So people can buy them initially, and then they can sell them between themselves in secondary markets. And like looking at listings of bonds, well, here's something that you might see, that there's a 3% coupon bond, so that will be fixed, right? That's preset, and it pays $1,000 at the end. It's a 5-year to maturity bond, and maybe, you know, some time has passed on the bond. That's another issue, but let's say it still has 5 years to go. So it was purchased and then resold, and it's selling for this price. So this is the auction. This is the price that people are offering for it. Okay, so investors are selling it. The holder of the bond is selling it for this price. So you have to figure out what is the yield, and then compare that to other bonds, or compare that to your risk tolerance, or what you're prepared, or what you require as a rate of return for investing in either this firm or this government body. So in this case, we have a different set of information. I actually have the price, all right? And the 3% tells me, so that's always going to help figure out the payment. So 3% times 1,000. This is the formula you have to remember or use. You can add it to your formula sheet if you want to print that out and use it. So this is the pattern of cash flows. And we want to figure out the rate. So entering this, now you see, now Ricardo got us a number, and he's right, it's 6.5%. So I presume he did this, right? He used the time value of money keys, because he would not have been able to solve this analytically. There is no analytical solution. There's no way to isolate the interest rate on one side. Okay, you can try, but you won't be able to do it, because this will have to be factored through, and then anyway, you can't do it. So if anything, using tables of discount factors and annuities, this is how these were estimated in the past, before computers were ubiquitous, before people had computers and calculators that are pretty much a computer in your hand. They used tables to estimate what the yield might be. All right, we don't have to do that anymore. So really embrace the power of computing and use it, although at the same time appreciate the relationship between these variables. This is the tricky part. The tricky part is remembering the signs. So this is where we have to balance out the positives and negatives. We will get the right answer as long as the present value is a different sign than the payments, coupon payments, and the face value of the bond, okay? They have to be a different sign from each other. And the storyline goes that I pay this much today to own the bond, and then I'm promised $30 every period and $1,000 at the end. So I would do it like that. Any questions? Do you want me to go faster? Do you want me to go slower? I feel like I have to dance and sing. I'm losing viewers. You really should take the opportunity to try these exercises together. Even if you're just jumping in and you feel like you have to start at the beginning because you haven't watched any videos yet, just start doing it right now, and there's no harm. So I'll enter this, so maybe there's people watching who haven't tried anything yet. All right, so I'm going to enter these values into the calculator. So I go into clear TVM, and it's 5 periods. The interest rate is what I'm trying to find, right? So the price was, oh, I have to go back already. $854.55. So $854.55. Make it a negative. That's the price. Present value of future cash flows. And then the let me go back again. So the payment is $30. I knew that, but I just wanted to show people who are trying to follow along. $30 payment, $1,000 face value, and that's always going to be the case in this class. But in reality, sometimes it's $5,000. And now I compute the rate, and look at that, 6.5%. Remembering that it appears as a percentage. Right. Let's find a different variable. Why don't you try this one? Try not to look at the notes. Try and just solve it. Let's find a different variable. Let's find the coupon rate. So you have to find what amount you're getting every period. Let me give you some minutes to do that. Okay, Ricardo's been right all along, but now he's a little trapped. Okay, so someone else has to help Ricardo along. He's been carrying the weight of the class in the chat. Anybody else want to try? Let's see, what I did here was remembering that the price is a negative and the face value to be received is a positive. Ask for the payment and you'll get $54.95. But remembering the payment comes from this formula of the coupon rate times the 1,000. So rather than multiplying, you have to divide to find the rate. So have a look at that. Try that. Verify you can enter that. So again, this might be a little confusing because you have to do two steps. One to solve with the calculator, but you're not finished because this is the payment, but I want the rate. So you have to do the step to get the rate. Did you get it now? All right. So bonds are a combination. Valuation requires a combination of an annuity and the basic time value of money formula to value the future cash flows. Okay, I'll wait, Ricardo. I believe I put the notes up with one page and with 2 pages. Let me verify that I did that. I have so many classes, I lose track of where I did what. Let me double check that I gave the notes. So you can print them, right? So you can print them out. No, I just gave them as, oh yeah, it's 2 slides. No, I did 1 slide page. Okay. So I can also print them. I'll mount them with 2 slides a page so you can print them easier. Not yet. All right, so just try that, work on that, make a note, and I'm going to move to the next item. And so another application here. So we're done with bonds for now. We're going to revisit bonds. We're going to revisit stocks as well after I introduce the idea of interest rate conversions. I don't know how better to say it. The case where you might have more than one payment period in a year, okay? So, or more than one payment. So if this is for annuities, And we'll get back to that. But first, I have the last formula. I realize I did not demonstrate the final formula on the formula sheet known as annuity with growth. If you have any comments, Ricardo, let me know. Very good. It's always going to be that, Ricardo. So make a note to yourself, mental note or on paper, that's where you go wrong, because most students go wrong there. And I try and emphasize it. So yes, you got to put, when you're solving for a different variable other than the price, remind yourself which is cash outflow and which is a cash inflow. Okay? Get your signs correct. All right, so here is an application using the annuity formula. But it's slightly different than the conditions that we set out. So what were the conditions for an annuity that we discussed? Can you guys list them in the chat? The conditions to use the annuity formula. One was level cash flows, right? They have to be the same. 2 was finite cash flows. And 3 was first cash flow 1 period from today. I'll say from valuation, or well, from valuation, from where you want the price. All right, so that was for the annuity. Those were the conditions. What's different here? Why is this not an annuity? Why can we not use the annuity formula? Why are we restricted from using the annuity formula? Which of those conditions are violated? Okay, that wasn't one of the conditions. Okay, so let's see. The payments are monthly, though. That's a good point. So when you solve problems of valuation, the first step is always actually, I'll write it like this. In valuation problems, the first step is to identify the timing of payments and convert all variables to the same frequency. That's step one. Do we need to do that here, or is that taken care of? The timing of payments, like you mentioned, are monthly, right? So these are monthly payments. And the first one is a month from now. And the interest rate is 5% monthly. And we're told about 30 years. We need to convert that to months. And that's what's done down here. So everything is in months, so we're okay. So we don't have to do anything special. So that's going to be what we talk about when we finish this set of notes. We're going to focus on this converting, right? Interest rate conversion. So we have to do. But we're safe for now. We don't have to do anything special. So back to the question. The original question was, which one of these is violated? What's violated is the first one. The cash flows are not level. The cash flows, however, are connected by a constant growth rate, and that's the one we have to correct. So that is more like a growing perpetuity. If you remember back, we talked about that briefly. So I'm going to use CF. So the cash flows grow at a constant rate G, and I'm out of space here. That's at, looks like an AF. At. Is that all right? Can you read that? So cash flows grow at a constant rate G. The finite cash flows. Okay, so yes, exactly, you're right, Ricardo, you wrote it. So that's it, the inflation, the fact that there's a rate of growth here. So what we have to do is modify the root formula. The root formula is actually the growing perpetuity formula. So we're going to handle this like we did deriving the annuity. We're going to derive the growing annuity formula in the same way. Here is the growing perpetuity, and this is the pattern, and these cash flows go on forever. But after the teeth payment, whatever size it is, I am not going to be receiving these, right? Because the annuity ends. So I need to remove those from my price or valuation. I have to remove the value of these. And what's the value of these that I'm going to remove? It's also a growing perpetuity. Let me make this fit. That's also a growing perpetuity. What is the value of the growing perpetuity? So if you look back, the growing perpetuity looks like C1. So this is the formula I taught you, but it's happening over here. So we're going to use the same approach. The only difference, I'm not at 0, but I'm at T. So I have to get the next cash flow. That's basically what you have to see, that it's the next one after 0. The pattern lets me still use the same formula, okay? So that they're separated by one period. So the price here has to be this first cash flow. So this acts like my C1 or my first cash flow, the whole thing, not just the C1. Whatever that number is, the next one basically. So this is PVT, the price here. So this is actually, if I gave it a name, I could call it CT plus 1, right? So it's just one after, but I write the whole thing in here because I want to show you something. I want to show the derivation of the general form. So maybe if you're not following right now, look at this again. You need to learn this technique. Just it helps you understand where everything is coming from, right? So what I'm going to do is put this number here over I minus G, and you can go back through the videos or go back through the notes you've taken about where this comes from. And And this is valuation here, so I need to put this amount, this lump sum amount now, I have to move it back to time 0. So I'm going to take the present value of a perpetuity, growing perpetuity of cash flows. I'm going to remove the perpetuity of the cash flows I do not receive and subtract them off. And mathematically, bear with me, I'll never ask you to prove this, but you need to learn this technique. This is what ends up as my result. Now you guys can practice mathematically showing this, but basically I pull this out, and what is this? This is the growing perpetuity formula, and this is the adjustment factor, okay? So that's all I really need you guys to know, but I also need you to be able to apply it. So this is the adjustment factor because it's a finite amount, just like the annuity formula had an adjustment factor because it was a finite amount, it wasn't a perpetuity. Also, I want to point out this formula only applies if I is not equal to G. Why is that? What happens if I equals G? If I equals G, it turns out this will be 0 on the bottom. And if I equals G, this will be a 1, and a 1 minus 1 makes a 0. So that will mean that you will have 0, let me put it on the top here. So you will have 0 divided by 0, which is indeterminate. It doesn't exist. So in other words, you cannot use this formula when I equals G. Now, is there no answer when I equals G? Yes. I mean, no, there is an answer. Is that the right answer? I said, is there no answer? No, there is an answer, okay? There is an answer, and what you have to do, you can't use this formula. You have to do it by first principles, and I'll show you an example of that. Anyway, you'll see it in the notes if I don't get there. All right, so this is the crazy formula. This is the most complicated, I'd say, for you. You just have to practice because, in fact, this is not programmed into your calculator. All right, so you need to enter that yourself. Or you can try it in Excel if you're comfortable with that, or you can use a scientific calculator if you're comfortable with that. But I'm trying to teach you because many of you are going to go on, you're going to be finance, your concentration is finance, and you need to learn how to use the finance calculator because I teach FINA 4125 and you're going to use it. So if you actually take the finance concentration, the same packet, I use the same packet for them, but I use more complicated exercises and I expect much more complex skills, okay, ability to solve more complex problems. But I use the same notes to teach the calculator. So you can aprovecha if you are a finance student. How many of you are going to be finance majors or are finance majors? You guys can let me know. I guess I can see that too. I have to check my class list. All right, so what do we do with this? This is the timeline. Notice the conditions that I wrote out here. I'm going to add one more condition. So these are the conditions for the formula, but I'm going to add one more. Okay, so the cash flows grow at a constant rate. They're finite cash flows, and the first cash flow is one period from valuation. And I'm going to add the fact that the growth of cash flows begins in period 2. A very important point If it doesn't happen that way, you can't use this version of the formula. You have to derive a different one. All right, so know the criteria to use this formula. All these steps, and I not equal to G is another one, but I'll just write it here. If you want, you can add it as a fifth. So putting these values in our calculator to get the result, it's almost 20 minutes after 5. So I am going to do this on my calculator, and then you're going to practice, all right? So what we have here, before I enter this into the calculator, I'm going to simplify this a bit, 0.003, and here goes. I'm going to do these keys. So 1.002 divided by 1.005, I got to go back to make sure. It's 5%, right? Okay. Equals, now that's in the brackets. I'm going to raise it to the power of 360, so 360 periods. Then I'm going to make it a negative and add to 1. So that's the square bracket. That should be this square bracket. I'm going to multiply by 100 and divide by 0.003. So multiply 100 and divide by 0.003, and that is my answer. It is worth $21,970.77. Did I go too fast? You want to see that one more time? Well, I guess you can watch the video, because I probably need to stop if students have other classes or places to go. Anybody want to see that again? So begin reviewing the problems on the platform. Go work ahead. I'm trying to put all these videos up, reviewing the material, key material. Send me your questions if you can't be here on Wednesdays or Mondays for the lecture or the lecture recording. As I promised, you don't have to attend the lecture recordings, but if you want me to respond to your questions, I can respond to them here. You can put questions also in the Foro de Dudas on the Moodle platform, all right? And I can respond, or other students can respond as well. So with that, I am going to sign off, and I wish you happy computing. Bye for now.